And today we will solve two problems, that is problem 2.17 and problem 2.18 related to Gauss law. This is from the Introduction to Electrodynamics, fourth edition by Griffiths. So the problem 2.7 is an infinite plane slab of thickness 2D carries a uniform volume charge density rho as given in the figure. The electric field as a function of y, uh, where y equal to 0 at the center. This is the y is 0 at the center at this point. I also plot E versus Y, calling E positive when it is in the positive, yes, positive Y direction, and negative when it is points in negative Y direction. This is the Y direction and this is the Z direction. Now, by definition, we know the electric field due to infinite plane slab is equal to sigma divided by 2 epsilon naught. But here the given parameter is rho, volume charge density. So the total charge is rho multiplied by the volume. That is, volume is here A, area into 2D, thickness, area into thickness. Then total charge using surface charge density is sigma A. And now this A will get cancelled. So here you can write sigma as rho multiplied by 2D. This we are going to use later stage also. Now you replace sigma by rho multiplied by 2D. So now 2 will get cancelled. So you will get rho d over epsilon naught. So the electric field is rho d over epsilon naught if modulus y is greater than or equal to t, that is outside, greater than or equal to d. So now we will move on further. Now consider yz plane. This is y and this is z plane, and we are considering one line which I have shown in the orange color, which is moving. Uh, what is the electric field uh, due to the along the positive y direction? That is this direction. Along this direction, that is you have charge from here to here and it is moving up to this. So what is the thickness? Thickness here it is y and this is t. So this is rho into t, thickness, not 2t. We are not taking full thickness. We are taking thickness up to this point, t plus y. So rho multiplied by t plus y divided by 2 epsilon naught. Then what about this direction? This direction you have to subtract y. That is, along this direction you have t and you have to subtract this y, minus y. So this is equal to minus, because we are taking in the opposite direction, there is a negative sign, minus rho t minus y divided by 2 epsilon naught. Now if you subtract this and this, you will get this t will get cancelled, and y minus of minus y is plus y. You will get 2y. E is equal to rho multiplied by 2y divided by epsilon naught. This 2 will get cancelled. So you will simply get rho y over epsilon naught. Now we have to plot the graph between y versus, this is y, and z-axis is E, y versus E. As asked in the problem, we have to plot the graph between electric field and y direction. Now, at y direction, What is the electric field along y direction? Electric field along y direction is rho into T divided by epsilon naught. So you got maximum. This is at the point T. And at the point minus T, also you will get rho T divided by epsilon naught here. Then what will happen between this point also T minus T here plus T, so you will get to 2T. What will happen to in between minus T to plus T? You can see this expression rho and the epsilon naught is a constant, so let it be C constant time y. E is equal to proportional to y, where this we can take as mx plus c straight line equation. C is 0, so it will go along the origin. So this is mx, where m is the slope, rho pi epsilon naught. So it will linearly increase proportional to y. So naturally this graph between minus t to plus t is a straight line, and after t this will not change. This is equal to rho d divided by epsilon naught to both side, here also and here also. So now we have solved problem 2.17. Now we will move on to 2.18. Now we will solve problem 2.18. Problem 2.18 is two spheres, each of radius r and carrying uniform volume charge density plus rho and minus rho respectively, are placed so that they are partially overlap as shown in figure. Here it is overlapping, there is a shadow. Call a vector from the positive center to negative center T. So this vector is T. So that the field in the region of overlap is constant, and find its value. So you take the point here at overlap, then find the electric field. What is the electric field at this point? Red color, I have shown in red color. From problem 2.12, the electric field inside the sphere is equal to rho r divided by 3 epsilon naught r cat. This is the, so here it is positive in this sphere. Rho is positive, here rho is negative. So now what will happen? Electric field due to this point. This is this distance is let us say this is r plus. So this is E plus, because we are considering the positive charge. So E plus can be written as rho r sub plus r cat plus divided by 3 epsilon naught. What will happen if we consider the negative charge? Then you take this distance. This is r minus, this distance r minus. So electric field due to this from here to here, this point under consideration is equal to E sub minus, because we are considering the negative charge region. Here rho is the negative, so this is equal to minus rho r sub minus divided by 3 epsilon naught r cat sub minus. So what is the total electric field? This is E sub plus plus E sub minus. So this field. If you take vector addition, then see, if you consider the vector addition, this vector is equal to r plus minus r minus. So what is the distance between r plus and r minus? It is naturally, this is t. So rho, you take this one, rho 3 epsilon naught is a constant. you can take r plus minus r minus. So distance between r plus and r minus due to vector addition, if you subtract this vector r plus with r minus, you will get the vector d. So rho divided by 3 epsilon naught d. Uh, so this is the final answer. Thank you very much for watching my video and supporting me continuously. Thank you very much.